In this video, we are going to study projections of solids. We'll start with pyramids. Let's read the problem. A pentagonal pyramid, base edge is 25 mm long and axis 45 mm long, has one of its base corners in HP. Axis of the pyramid is inclined to HP by 40 degrees and top view of the axis is inclined to VP by 30 degrees. Draw projections of the pyramid if its apex is towards the observer. Now, what is the shape of the object? It is solid, a pentagonal pyramid. Pentagonal pyramid. Pyramids are identified by shape of their base. So this pyramid has a base, a regular pentagon. So it has 5 base corners and one more corner at top, that is apex. So overall 6 corners this object has, 5 base corners plus apex. Then how many edges this object has? 5 base edges, because base is a pentagon. 5 base edges and 5 face edges. From each base corners up to the apex, that is a face edge. So there are 5 face edges and 5 base edges. Now what is size of this object? Shape is pentagonal pyramid. It is a solid shape, and size is length of base edge is 25 and axis length. Axis is an imaginary line joining center of base and apex. That is also called height of the object, and that height is a 45 millimeters. So we know size and shape of the object. Now its position with respect to HP and VP is explained in the problem. Read it carefully. One of its base corners in HP. So out of 5 base corners, it is pentagonal pyramid, don't forget. Out of 5 base corners, 1 base corner is in HP. That means this pyramid is standing on HP on one of its corners. Axis of the pyramid is inclined to HP by 40 degrees. So this pyramid is inclined. What does that mean? This pyramid axis is inclined to both the reference planes HP and VP. So draw projections of the pyramid if its apex is towards the observer. So what we are going to study, if it is a pyramid and if its axis is inclined to both the reference planes, how to draw its projections. So we draw projections in 3 stages. Which are the 3 stages? You will come to know now. Since this is the first problem on projections of solids, we are going to study it in detail. Also, while studying the problems, we are going to note down our observations as points to remember. And you will have to remember these points, and these points are going to help you to solve problems. So when you read the problem, you should write the information in the problem as data in 3 parts in this manner. First, check shape of the object and its size. So it is pentagonal pyramid, length of base edge is 25 and height nothing but length of axis is 45 millimeters. Then what are the details about its position with respect to HP? So check. A base corner is in HP, it is mentioned, one of its base corners in HP. What else? Its inclination of axis with HP is 40 degrees. We have already studied projections of lines, and from that chapter you know we use notation theta for true inclination of a line with HP. So that is why I mentioned here theta axis. Now when it is a pyramid, or a solid object, then we can identify infinite lines on the body. Those lines can be diagonals, diameters if it is cone or cylinder, base edges, face edges, axis, etc. So when you say true inclination of a line with HP, which line is it? So in this case, it is inclination of its axis with HP is 40 degrees. What else we have? We know here it is top view of axis. Now we know that in projections of lines, beta is the notation used for inclination of top view of a line. So here this line is axis. So axis, top view of the axis makes 30 degrees and also apex is away from VP. So check how we have noted down the information given in the problem. Here it is shape and size of the object, here position with respect to HP, and here position with respect to VP. And now proceed in this way. Draw first of all XY line. Set your roller with horizontal edge of the paper and draw XY line. Label immediately XY line. Now set a protractor in this way. Its axis of symmetry is along XY line, so that you will able to draw a vertical line which is perpendicular to XY line. Now this is right now construction work, so these lines are faint lines. Now along this vertical line you measure 25 millimeters as one of the base edges. Make it dark because it is an edge, it is one of the base edges. Now at these two ends of this vertical line 25 millimeters long, you measure 108 degrees at the lower end also, and transfer this 25 millimeter distance along these two inclined lines. This 25 millimeter distance you transfer along these two inclined lines this way. Now from these two newly marked points, draw with the same distance 25 millimeters intersecting arcs in this manner. So this is how you have completed a regular pentagon. Make all the 5 edges dark because these are base edges of the object. We should always draw edges dark and all other lines faint lines. Now this is a regular pentagon. It is a true shape of the base of the object. Now label all these corners in alphabetical order, starting from letter A. So I have labeled all these 5 corners as A, B, C, D and E. It will be a standardized labeling we are going to use. When it is a top view, don't use a dash. So we have labeled this corner as corner A, that means it is top view of corner A. But these are only base corners. This object is a solid object, it is a pyramid, so one more corner and that is apex. In the top view, that apex lies exactly at the center of this pentagon. So you will have to locate center of the pentagon. Set roller with XY line. From corner A, draw a horizontal line. This horizontal line, watch here, this horizontal line passes through the center of the opposite edge. Now one more corner to be connected with center of the opposite edge, and for that purpose use this construction. Take any distance as a radius and from two ends of one of the edges, जैसे here in this case edge DE, from point D draw an arc and also from point E draw intersecting arc with the same radius and join this point of intersection with opposite corner B. This is how you have located center of the pentagon. Label it as a point O. This point O, we are always going to label apex with letter O. So that means this is top view of point O. Now draw all face edges. So join point O with base corners one by one. So OA, OB, OC, OD and OE. These are all face edges. So there are 5 base edges and 5 face edges. And remember, standardized labeling is very important. In the views, you will able to identify base edges and face edges from these labels only. When you read in alphabetical order from point A, AB, BC, CD, DE and the closing side of the pentagon, that is EA again, These are base edges, and face edges you can identify as edges from point O up to base corners. So OA, OB, OC, OD and OE, these are all face edges. So all 5 face edges meet at apex. So this is top view of the pyramid. Now front view of the pyramid, how to draw it? So initially, don't worry about the given position of the object. This is the first stage of the object. It is imagined position in which we imagine object standing on its base. So entire base is in HP. That means all base corners are on XY line. So set roller with first vertical line on the paper and draw projectors from all 5 base corners and apex. In this way. Now note here, apex is always above the base, but base corners are on XY line. So label front views of these base corners as A dash, B dash, C dash, D dash, E dash. So all 5 base corners in front view are on XY line. That means all 5 base corners are on HP. Means entire base is in HP. Make it dark. Now measure height of the object vertically. That is 45 millimeters. And here it is apex. Now join apex with all base corners. These are all face edges in the front view. So here it is O dash C dash and O dash D dash. 2 face edges are coinciding here. Then O dash B dash and O dash E dash. 2 more face edges are here which are coinciding. And finally the 5th face edge OA. So O dash O dash, O dash B dash, O dash C dash, O dash D dash and O dash E dash. These are 5 face edges, and base edges you can identify here. A dash B dash, read in alphabetical order. A dash B dash, B dash C dash, C dash D dash, it appears a point. Now when an edge appears a point in the front view, that means that edge is perpendicular to VP. Watch here, in the top view you can clearly say that edge CD is perpendicular to VP. It makes 90 degrees angle with XY line. Okay. So here this is first stage or first pair of views, front view and top view. First pair of views, top view below XY line and front view above XY line, because you all know that we use first angle method of projections. Okay, now in second stage we are going to bring details with respect to HP on paper, and in third stage we'll add details with respect to VP. So in the third stage you will get all the information about position. In the second stage you will get information about HP only. That means the final stage is the given position in the problem, that is final drawing. Now you try to understand. To bring the object in given position, what appears at the boundary of this triangle is very important. What does I mean? In first stage, remember carefully, in first stage you always draw views in such a way that a view gives a true shape of base and the other view gives true length of axis. Here this blue line, longer dash, shorter dash, this blue chain line is axis. Don't make axis dark, because axis is not an edge, it's simply an imaginary line. So length of the axis, that is from center of base to apex, is 45 millimeter. Length of axis is nothing but height of the object. length of axis view, listen to me very carefully. Always, as I told you, that we are going to remember all our observation as points to remember to solve other problems on predictions of solids. So remember this way, true length of axis view of a pyramid has boundary shape, a triangle. Boundary shape of boundary. Watch the boundary of this figure. You will realize that it's a triangle. So true length of axis view of a pyramid is always a triangle. Now boundary of the triangle is very important. All features at the boundary are very important. If you are sure about those features, you will able to bring the object in this given position. So what are those boundary features? Features appearing at boundary of this true length of axis view or front view. Check. This is that outlined shape. Just check the boundary. Here it is top corner. It is nothing but front view of apex. So top corner, here it is apex. Then this corner is a base corner. Which base corner? As per our labeling, it is corner A in the front view. And this corner of the triangle, it is not just a corner, it is base edge. Which base edge? CD. This is base edge CD. In front view, top view, here it is base edge CD in the top view. And here it is base edge CD in the front view. So here it is a corner apex, here it is a base corner, and here it is a base edge. Now what about the three boundary lines for this pink colored triangle? O dash A dash. It is a face edge. Which face edge? OA. This is front view of face edge. Where is top view of this face edge? It is here, OA. Now just focus on edge OA and you will realize that top view is parallel to XY line. That means front view gives a true length. So this edge O dash A dash in the front view is showing true length of face edge. Now this edge, it's not just an edge. If you read it carefully, OCD, matlab this edge is a triangular surface. That is a face of this pyramid. Watch here, this surface OCD in the top view. It is triangular surface. It is one of the faces. This pyramid is pentagonal pyramid and therefore it has 5 faces. In case of a square pyramid, it has 4 triangular faces, and hexagonal pyramid has 6 triangular faces. This is pentagonal pyramid and therefore it has 5 triangular faces. Out of those 5 triangular faces, this face OCD appears a line in the front view. So this boundary in the front view is not just a line, it is a triangular face of the object. And this base of the triangle is not just a line or base of a triangle, it is actually the pentagonal base of this pyramid. This is pentagonal base of the pyramid. Okay, these boundary features are very important. Now, temporarily forget what is given in the problem. First stage is always true shape of base view and on the other side true length of axis view. So this is how you get first pair of views. True shape of base. In a view you get true shape of base and in the other view you get true length of axis. Opposite to the true shape of base you always get true length of axis. And true length of axis view is always a triangle. Now for second stage we rotate true length of axis view. That is, this is way. This is how. Here I have rotated true length of axis view in such a way that now this pyramid is standing on one of its corners. But then you can rotate it for certain angle and it can be angle of its base. For example, here it can be angle of base, let's assume, or let's say 30 degrees. So this is the position we can describe as the pyramid is standing on one of its base corners with base making angle 30 degrees with HP. Now one more observation here, axis is always perpendicular to base. So if base makes 30 degrees with XY line, certainly axis makes 90 minus 30 degrees, means 60 degrees. Now any position with corner on HP we can have in our drawing paper in this way. Visualize the rotation of the front view. Whatever the angle you want or distance of any point, say apex is certain distance from XY line, that you can manage. This corner, as I have already explained you, is base edge. If you want this corner, that means one of the base edges at certain distance from HP, that you can manage here. You can manage angle of base, you can manage angle of face edges, one of the face edge, you can manage angle of this face also. Right now this face is making certain angle with HP, any angle you can have by rotating the front view. I am further rotating it, check here, still one of its corner is in HP, but now the position is in such a way that one face, in this case face OCD, is parallel to HP. So you can have object in this position if you are asked to draw. That is, a corner is in HP and face opposite to the corner parallel to HP. If you further rotate, for any angle you can rotate, or now in this case check, edge OA, that is one face edge is in HP, front view on XY line means that edge is in HP. So edge OA is in HP. So that means all details with respect to HP you can bring on paper by rotating front view. So this is our initial position. Now instead of a corner, if you want a base edge in HP, you can rotate in this way, and then as per the angle given you can give any position to the object. Now this position I have shown right now in the diagram, in this case one entire face is in HP. Here it is face is in HP, OCD. Okay, now let's come to this problem. Which position we want in the problem? Now this is very important to understand. In second stage we are going to bring details with respect to HP on paper, and details with respect to VP you will get it in third stage. So right now forget all details with respect to VP, just focus on details with respect to HP. And front view gives details with HP, and that's why you should move front view only. So a base corner in HP, right now in this diagram, in first stage all base corners are in HP, but we want only one base corner in HP. So this is how we are going to do it. Try to understand first. First try to understand, and then I'll explain you how to draw it properly using your drawing instruments. Okay. So here this is the first position I've shown in second stage. We want corner A on XY line. But now we want axis inclined at 40 degrees. Now axis is inclined at 40 degrees. It means that base is inclined at 50 degrees. So base and axis are perpendicular to each other. So if you have base at 50 degrees, automatically you will get axis at 90 minus 50 degrees, that is 40 degrees. So this is the required position. Check here, front view gives all details with respect to HP. So a base corner is in HP, yes, corner A is in HP, and axis is inclined at 40 degrees. Yes, this axis is certainly inclined at 40 degrees with HP because the base is inclined at an angle 50 degrees. So you are going to draw front view in second stage in this manner to bring all details with respect to HP. But before you start drawing this view, you must know that you are not going to change size and shape of the front view. That means this triangle with all these labels is identical here. Only thing is we have rotated it. We have moved it. We have moved this triangle or front view for details with respect to HP. We have moved this triangle, in fact we have rotated it about corner A so that base makes 50 degrees and a corner is in HP. Base makes 50 degrees means certainly axis makes 90 minus 50, that is 40 degrees. So how to draw now this front view in second stage in this way? Let's study. First of all, mark a point at a convenient distance. This distance is slightly greater than this base length in the front view. This is corner A. Out of these 5 base corners, one corner you are going to keep it on XY line. First confirm that corner A is position A dash. Now at this corner A dash, we'll complete this triangle in required position, because outlined shape is a triangle. Outlined shape is a triangle, so only this triangle is to be reproduced here for this position. So one base corner is in HP. Now at corner A here in the second stage, use protractor, measure 50 degrees and draw a thin line first. Now on this thin line you are going to transfer this base, and since it is identical diagram you are going to draw, this identical base only tilted by 50 degrees, you are going to draw it here. So take this distance in compass, take this distance in compass, that is the base, and transfer it here. So this point A dash to C dash D dash, this distance we have transferred here, matlab here this point is C dash D dash. Now take this distance in compass OCD. So from point CD to point O, this distance you have taken in compass, and here from CD you draw an arc. And now take distance A dash O dash in compass, and from A dash you draw intersecting arc, and this is point O dash. So this is that required triangle we have completed. If you join O dash with CD and O dash with A dash, you will get the required triangle. But it is not just a triangle, it is front view of a pyramid. So all corners you are going to transfer here. So take this distance in compass, that is E dash B dash to be transferred here. So from A dash, check here, take distance E dash B dash in compass and draw an arc here. So I have transferred this distance here. So this is how all 5 base corners and apex are there in second stage. Now join apex with all base corners. Here now I am transferring the axis. So lowest point on the axis, that is nothing but the center of the base. Take that distance from A dash in compass and transfer here, and then complete the axis. Now from all these points, draw projector. So set roller with first vertical line on paper, then roll the roller, and from C dash D dash, in fact from all 6 corners, 5 base corners and apex, you are drawing projectors. Now from E dash B dash, now I have drawn projector from A dash, and now I have completed projector from O dash. Similarly, draw horizontal lines from adjacent top view, lines parallel to XY line. So set roller with XY line and check from point A, and it is also from point O, a horizontal line. So I have drawn this horizontal line. Now vertical line through O and horizontal line through O from adjacent top view, here it will be point O, means apex in the top view. Similarly, vertical line through A and horizontal line through A, where they intersect, you will get point A in the top view. So it's very simple. Simply from all the 6 corners from adjacent top you draw horizontal line. So from B, from C, from D and from E. And now carefully identify these 5 points, horizontal and vertical lines from each from corresponding points. You will get the new top view of the point. So vertical line through O, horizontal line through O. Vertical line through A, horizontal line through A. Here it is point A. Vertical line through B and horizontal line through B. Here it is point B. And this is how you have now all 6 corners in the top view. Now how to complete the view? Because we have changed the position of the object, this pyramid. That means some of the edges which were visible initially might be hidden now. So how to identify hidden edges, visible edges and complete the view? Try to understand. First of all, with very faint pencil, confirm the base. Base is a pentagon A, B, C, D, E. So join in alphabetical order and complete the pentagonal base. So this is how we have completed the pentagonal base, but right now I have not made the pentagon dark. The base A, B, C, D, E in first stage and base A, B, C, D, E in second stage, you will find that in first stage it is true shape of the base, but in second stage the base shape is distorted horizontally. We are going to call it as horizontally compressed shape of the base. And always, this is what I am telling you, these observations in this problem are going to become rules in the remaining problems we are going to solve. So you always get in second stage base horizontally compressed. Okay, now join apex with all base corners one by one, but faint pencil OA, OB, OC, OD and OE. So this is how all 10 edges are there. Now listen to me very carefully. You never have hidden edges at boundary. So make boundary edges dark. So all edges which appear at boundary you have made dark. Then after making boundary edges dark, just compare center of base and apex in the front view. Which point is closer to observer? It is comparison between center of base and apex. This is top view, and for the top view observer is watching from top. So when observer is at top, apex is closer to observer. What does that mean? Base is hidden, and if base is hidden from top, then in the top view make the base edges which are inside the boundary hidden. So I made these two base edges hidden. If base is hidden from top, doesn't mean that in the top view all base edges are hidden, because you never get hidden edges at boundary. So only those base edges which are inside the boundary you are going to draw hidden. Next, there are 3 face edges OA, OC and OD. These 3 face edges we have not yet made dark. Check here that 2 edges, when observer is observing the object from top, you will find that edges OC and OD are nearest to the observer, and therefore those 2 edges are visible. And edge OA is the lowest face edge, and that is hidden. Now to solve problems mechanically very quickly, remember in this manner, face edges over hidden base are always visible. So base is hidden, you know, when you watch this object from top, apex is towards observer, means base is hidden. Base is this pentagon in the top view. So all face edges which are partially or fully on this pentagon are visible certainly, and therefore OC and OD are visible. Boundary edges are of course always visible. So boundary edges are visible. face edges over hidden base are visible. This is the only face edge which is hidden, OA. Now let's locate axis in the top view. So axis is from center of base to apex. So this lowest point on the axis, now we are going to transfer in the top view. So the way you have drawn projectors from all corners, let's draw projector from center of base. Watch here, this line I have drawn here. And from adjacent top view, center of this pentagon, draw horizontal line which is already there, and here it is center of base. So in the top view, we have identified now center of base. In second stage, here is center of base and here it is apex. Now if you join center of base and apex, that is axis. But listen, if axis coincides with an edge, we don't draw axis. In this case, from center of base to apex, if you draw that axis, it will coincide with edge OA in the top view, and that is why here, even if we know that from this point center of base to the apex it is axis here, we must not draw axis. Now what is the length of the axis here? From center of base to apex it is axis. What is this length? It is certainly shorter than true length. It is less than 45. So it means that this is a planned length of the axis. This is not true length of the axis. True length of the axis is here, 45 millimeters. True length of axis is here, 45 millimeters, which we have measured already. And since these two diagrams are identical, except that rotation or inclination, shape is identical, and that is why here length of the axis is also 45. So here in the front view, axis shows true length, but in the top view, axis is not showing true length, so it is a PL, plan length. Okay, so in the second stage we have brought all these details on HV. Now let's complete the third stage. Top view gives details with respect to VP. Now what top view says, what are the details given with respect to VP? Top view of the axis makes 30 degrees, but in our diagram top view is parallel to XY line, means parallel to VP. We should make it at an angle 30 degrees. We should draw it at an angle 30 degrees. So how to do it? Try to understand. Now we are not going to change size and shape of this top view. We are going to rotate the top view for these details. We are going to move this top view for these details. So imagine that you are just going to draw the same diagram here for these details. So you are going to rotate this diagram in short by 30 degrees. So how to draw it? Try to understand. Set roller with XY line. Draw a faint horizontal line just as a reference line to measure the angle 30 degrees. Mark point O. This point O is apex of the object now, and top view of the axis we want at 30 degrees. So measure 30 degrees. So draw first of all faint line. So this axis of symmetry of the diagram, watch here, this line passing through O, this line we have drawn at an angle 30 degrees because on this line top view of axis is. Now take the distance PL in compass. Take this distance PL in compass and transfer it here. So now the point which we have marked is center of pentagon, that is the top view of axis is complete, plan length. PL always has angle beta, so here it is angle beta is given, so we have measured top view of the line, means axis 30 degrees. Now on this line point A is, so let's take that distance of point A in compass, watch here this distance and transfer here. So this is point A. It's same diagram we are constructing here, and therefore use compass to transfer the distance. So here it is point A. Now, important thing, all 6 corners to be transferred. Out of 6 corners, which 6 corners? 5 base corners and apex. Only 2 corners we have labeled here. Where are the other 4 corners? So C and D, this line CD is perpendicular to the axis of symmetry. Also check line joining point B and point E. This faint vertical line is also perpendicular to the axis of symmetry. That is why, first of all, transfer the points, corresponding points on the axis of symmetry. Here it is edge OA I have drawn here. Now watch here these 2 points. This point where CD intersects axis of symmetry, and this point where line BE intersects axis of symmetry. These 2 points will transfer here. So take this distance in compass and transfer here. Also take this distance in compass and transfer here. Now use protractor as usual to draw perpendicular lines. Set axis of symmetry of protractor along axis of symmetry of the diagram and draw these perpendicular lines this way. Now on corresponding lines transfer these points. So check here, take this distance in compass, and by symmetry point D is also at the same distance. So take this distance in compass and transfer it here this way. So these 2 points are point C and point D respectively. Now take this distance in compass for B, and same is the distance for point E. So take the distance in compass and transfer here. So here I have transferred points B and E. So check here, A, B, C, D, E is base, this pentagonal base, and then you will join point O with all base corners. In fact, here you need not worry about hidden and visible edges. Just remember, it is the same diagram to be completed here. So all edges which are hidden here in topy of second stage will appear here hidden. So simply refer this diagram and complete. Boundary dark, and this is how we have completed the diagram. Now for the final diagram, again draw projectors to complete the front view. Now since we have rotated the object to bring all details with respect to VP, the front view has changed. So how to complete the front view? As usual, draw projectors use a roller scale and draw the projectors from all the 6 corners. So from all the 6 corners I have drawn this vertical line, and from adjacent front view draw horizontal line. So from O dash I have drawn horizontal line, and there is already a vertical line through O, that means this point is point O. Similarly from all these corners, so for C and D it will be a single line, from B and E it's horizontal line, and for point A it's the XY line itself is the horizontal line. Now vertical line through point O, horizontal line through point O, that is point O here. And since it is front view, use dash. Similarly, vertical line through point A and horizontal line through point A, here you will get point B. Vertical line through point B and horizontal line through point B, here you will get point B. Similarly, point C, point D, vertical line through D and horizontal line through D, here it is point D, and finally point E. Now how to complete the diagram? Now position of object has changed. So how to identify hidden and visible edges? Try to understand. It is a similar procedure here. First of all, complete with faint lines pentagonal base. Join all base corners with apex OA, OB, OC, OD and OE. Now boundary edges are always visible, so make boundary dark. And then now from front means from here, check apex towards observer. It means a base is hidden. So if base is hidden, it doesn't mean that all base edge is hidden. Base hidden means inner edges of the base, that is inside the boundary edges of the base are hidden. So make those edges hidden. So I have drawn the remaining 3 edges hidden. And since base is hidden, face edge over hidden base is visible. So only this face edge inside the boundary is visible and the other 2 are hidden. So this is how we have completed the drawing. Remember this statement: face edges over hidden base are visible and boundary edges are always visible. Edges at boundary are always visible and face edges over hidden base are visible. If apex is towards observer, जैसे in this case to draw front view, observer is watching from front. If apex is towards observer means base is hidden in the front view. So make inner edges of front base hidden. So this is how we have completed the drawing. Now we are going to observe this drawing carefully and draw some rules, draw some conclusions, and we'll remember those conclusions as rules. Try to understand. One more thing. Remember, if axis coincides with an edge, in this case center of base to apex is axis, but if you draw the axis it will coincide with edge OA. If axis coincides with an edge, we must not draw axis because edges are important. Now let's check, can we draw axis here? So axis is always from apex to center of base. So let's look at center of base. So from this point center of base, you should draw vertical line, and from center of base, that is nothing but lowest point on the axis, you should draw horizontal line. So watch this red colored line here. And from this point in the top view, center of base, I am drawing a vertical projector. So this is how we have located, check here, center of base. Now join center of base with apex. Check this thin blue colored line I have drawn here as axis. So this is axis in the front view. Now, what you have studied in this are few important points you should remember. I'll tell you. When you draw views of a solid where axis of solid is inclined to both the reference planes, then this is the flow chart we use. Try to understand. I am giving you a flow chart. Stage 1 is convenient position, where we draw true shape of base view, and on the opposite side you get true length of axis view. So here we have drawn true shape of base view of the object that shows true shape of base, and on the opposite side true length of axis view. So below xy line true shape of base, above xy line true length of axis view. Then we rotate true length of axis view in stage 2. Check here. And then we get horizontally compressed base view. Always we get a view with base horizontally compressed. Then in stage 3 we rotate horizontally compressed base view, and final view is here. So this is the flow chart. This is how we have completed the drawing. Now first rotation and then second rotation. So in stage 2 we rotate a view, and in stage 3 we rotate the other view. In this case we have rotated front view, and then we have rotated the top view. While rotating front view, take care of all details with HP. Remember, these are all very important points, because front view gives details with HP, while rotating front view take care of details with HP, and while rotating top view take care of all details with VP. Remember, while rotating front view take care of all position details with HP, and while rotating top view take care of all position details with VP. So once again remember, this is the flow chart. Note down somewhere in your notebook. First stage, true shape of base view, true length of axis view. Rotate true length of axis view, you get horizontally compressed base view, and then rotate horizontally compressed base view for stage 3, and you get the final view. So stage 3 brings all position details on paper. So this is the final drawing. Stage 3 is final drawing. There are 2 rotations involved, remember. Now sometimes it all depends on information in the problem about position. Sometimes we draw true shape of base view above XY line. We are going to solve some more problems in subsequent videos. So what I am telling you is, sometimes we draw true shape of base below XY line, and sometimes we draw true shape of base above XY line. When we draw true shape of base view above XY line, then true length of axis view you get below XY line. But first rotation is always true length of axis view. So check here, true length of axis view here, in this case true length of axis view is above XY line, and in this case true length of axis view is below XY line. We first rotate true length of axis view. When we rotate true length of axis view, we get horizontally compressed base view. So that is stage 2, and then we rotate horizontally compressed base view to get the final view. So check in case 1 flow chart and check in case 2 flow chart. This is how we have completed the drawing. Remember again, there are always 2 rotations involved if axis is inclined to both the reference planes, and while rotating front view take care of details with HP, and while rotating top view take care of details with VP. Now what is in the problem that suggests us to draw true shape of base below XY line, or to draw true shape of base above XY line? That you should understand. And one more thing, the orientation of true shape of base. You will understand what I am saying. Draw true shape in HP. As I told you, 2 cases here. Check. I have told you 2 cases. I told you that sometimes we draw true shape of base below XY line. Sometimes we draw true shape of base above XY line. But how we take that decision, that is what I am explaining here. Draw true shape in HP if face inclination with HP is given. Read problem carefully, check the position details, and if face inclination with HP is given, then draw true shape in HP. Or if top view shape of a surface is given, draw true shape in HP. Or if it is mentioned that base edge is in HP or parallel to HP, then draw true shape in HP. And finally, if it is resting on HP, on a corner or on an edge, then draw true shape of base in HP. Now when I say that face inclination is given, say face is inclined at 30 degrees to HP, or face is inclined to HP by 50 degrees, etc. If face inclination with HP is given, remember that is, it also includes face in HP or face parallel to HP or face vertical. Face vertical means it makes 90 degrees with HP. Face parallel to HP or face in HP means it makes angle 0 degrees with HP. So if face inclination with HP including all these positions of faces, then you should draw true shape in HP. So what information in the problem is very important. If face inclination with VP is given, draw true shape in VP. If front view shape of a surface is given, draw true shape in VP. If base edge in VP or parallel to VP given, then draw true shape of base in VP. And if object is resting in VP, means if any portion of object is touching VP, then you draw true shape in VP. Resting on HP means a portion of object, any feature of object, say corner or edge, is touching HP, then we say that it is resting on HP. And if any feature of object like base corner, base edge or face touching VP, then we say that object is resting on VP. So here, this information here is very important. It helps you to decide where true shape of base is to be drawn. Now one more thing. If it is a triangular pyramid, then it has true shape of base equilateral triangle. If it is a square pyramid, then it has true shape of base square pyramid. True shape of base a square. If it is a pentagonal pyramid, then it has true shape of base a pentagon, and hexagonal pyramid true shape of base is hexagon. But sometimes we draw true shape of base in this orientation, sometimes we draw in this orientation. So I made two columns. You may face a triangular pyramid or square pyramid or pentagonal pyramid or hexagonal pyramid to draw. But what is speciality of these two columns? Try to understand. In this column, for all these shapes, on the right side I have drawn an edge vertically. So this equilateral triangle has one edge vertical, but on the right side it has one edge vertical. This square has one edge vertical on the right side. Similarly, this pentagon and hexagon. And here it has a corner placed symmetrically, but on the right side. Check here. So triangles, two positions for projections of solids, where solid is inclined to HP, VP or both. Then either we draw equilateral triangle in this manner or in this manner if it is triangular pyramid. If it is square pyramid, we draw square in this manner or in this manner. But what is important is which is the correct position out of these two positions. That depends on what information given in the problem. If it has a corner in the reference plane, then we draw it in this manner. And if it has base edge, then we draw it in this manner. Base edge in or parallel to reference plane, then we draw it in this manner. Also, when face inclination with the reference plane is given, face inclination with reference plane is given, or face is in HP, including face in HP or parallel to HP, then we draw true shape of base in this orientation. And if corner is in the reference plane, then we draw true shape of base in this orientation. So let's compare this information with the problem which we have solved. This is the information about position in the problem just now we solved. It has a base corner in HP, means object is resting on HP, and that is why true shape of base we drew below XY line. Below XY line. Because in first angle method of projection, below XY line is HP and above XY line is VP. So base corner in HP, that's why we have drawn true shape of base in HP, means below XY line. Then it has a corner in HP, and that is why we placed one corner on right side and completed the pentagon. So why position of pentagon in this manner? Check here again. We have drawn pentagon in this manner because it is resting on HP on one of its corners. That is why I managed pentagon in this way. So that's all for this video, and we'll solve some more problems in my next video. Till then, thank you. Bye bye.